The global energy industry is undergoing an accelerated transformation towards cleaner energy generation sources and technologies. As new types and applications of energy generation and storage come into the mix, it can get a bit confusing to differentiate between their purposes, benefits and shortcomings. Today, we're going to talk about pumped hydro energy storage and how it differs from standard hydroelectric power. While these technologies look similar at a glance, they serve two different purposes in our electricity network. They are also both frequently referred to as just hydro, which can make it a tad tricky to know which is which. By the end of this video, you'll have a better idea of what they're used for and how to tell them apart. So, let's get energy explaining. Let's start by looking at hydroelectric power, or hydropower for short. This involves using flowing water to generate electricity. To do this, we take water from a high point and run it down a series of large channels to a low point. Inside these channels sits something called a turbine, which spins when water passes across it. The spinning turbine generates electricity. There are a couple of different designs of hydroelectric power stations, depending on whether they are built into a reservoir or a waterfall. Inside a hydroelectric power station will be located at least one turbine generator. Again, there are a few different designs of hydroelectric turbines, but they'll look something like this. Hydropower stations are most common in areas with an abundance of flowing water. In Australia, Tasmania is the largest producer of hydroelectricity, which makes up 80% of their total electricity supply. So how does pumped hydro energy storage, aka pumped hydro, aka PHES, because engineers love acronyms, come into the mix? Pumped hydro is a form of hydroelectric power generation which has been around for over 50 years. Just like hydropower stations, it's designed for water to flow from a high point to a low point through a turbine and generate electricity. But here's the difference. Pumped hydro is also designed for the water to move back up through the pipes to the reservoir at the top. Now, the water needs a bit of help to move uphill, so as well as producing electricity using downward flowing water, pumped hydropower stations are also designed to consume electricity to power either the same turbine in reverse or a separate water pump to move that water back uphill into the reservoir at the top. Because of this feature, the design of pumped hydro water catchments are slightly different to a standard hydroelectric power plant. The higher point of pumped hydro will always be a dam or reservoir, not a river or a waterfall. The lower point can either be a naturally flowing water resource or another reservoir. We refer to these as either open loop or closed loop designs. The design of the water channels is also slightly different too, to make sure the water can be pumped back up to the top. Because we have the option of building between two reservoirs in the closed loop system, pumped hydro storage can be built in more locations than hydroelectric power stations, as a constant source of flowing water isn't required. So, it's fair to say we can appreciate the purpose of channeling water downhill to produce hydroelectricity, but why bother consuming electricity to move the water back up to the top? The answer lies in the name of this technology, pumped hydro energy storage. These storage systems were originally designed to support large coal and nuclear power stations in the 1960s to 80s, which weren't very good at the time at increasing or decreasing their power output. At times when the demand for electricity was less than the station's output, where you see the blue line below the black line, the excess from the power station would be used to power that turbine and move the water uphill. When our demand for electricity was greater than their power output, which is when the blue line is above the black line, the water would then be released downhill, making hydroelectricity and making up the gap. The need for pumped hydro to support coal and nuclear power kind of evaporated, pardon the pun, over the years as cheaper and other more efficient forms of gas-fired technologies came into play. However, a new application for pumped hydro has emerged with the increase of renewables being installed in our grid. One of the largest challenges we face with renewable energies like wind and solar is we can't control how much the sun is shining or how much the wind is blowing. This means renewable electricity can be produced when we actually don't need it, or when we need it, it's not available. Pumped hydro allows us to capture electricity from renewable technologies that would otherwise have been wasted by using it to pump the water uphill. For solar power, this typically occurs in the middle of the day, when the sun is shining brightest but our power demand is low. When we run short of solar energy, say at nighttime or on a cloudy day, we can then release the water back downhill, regenerating hydroelectricity rather than using fossil fuels. Pumped hydro is just one form of energy storage which can be used to capture renewable energy. There are many other existing technologies and new innovations which can store energy that are supporting the transition to a more sustainable energy future. All these technologies have their merits and their shortcomings, which we'll explore further in future videos. I hope you enjoyed this video and now have a better understanding of the difference between hydroelectricity and pumped hydro storage. As always, I'd love your feedback and ideas, so let's continue this discussion in the comments. Thanks for watching Energy Explained.